Happy Monday, everyone. It's March 30th. Just wanted to say good morning. Welcome to your Algebra 2 class. Might have noticed I got a little different background. I moved out of my kitchen into my living room. Actually, dining room, living room. I don't know what to call this room, but kind of give me a little more sunlight in here, and I like the backdrop with the American flag. So anyhow, good morning. Glad you guys made it. Hopefully you had a wonderful weekend. Quite a crazy storm last night. If you had some lightning and thunder over here in Johnston. Some of my friends in Massachusetts got some hail, but we survived the storm. Didn't lose electricity, and I did watch the living room concert. I don't know if any of you guys caught that as well. Keeping my social distance. Some of you may have known this. I don't know, because I did mention it here and there, but this weekend was my birthday, so thank you. I heard you say happy birthday. Don't feel like you have to email me or anything, but all I'm getting at is how to keep my social distance, but I had two friends knock at my door, run back to their car, and I'm like looking out my window, and they both brought me birthday cakes, which was really kind of kind. So and they live right up the street. So they were out shopping because I was like, you shouldn't have gone out of your house. But they were like, we're out anyways, and we were thinking of you. So I did get two birthday cakes, and well, I guess I'm really not complaining. It's a good thing. But that's how my weekend went. I was like, I hope you don't mind. I'm not going to invite you in. They're like, no. We're keeping our social distance. But we had a mini conversation from my door to their car, and that was about it. So that was my weekend. I'm rambling, but I hope you had a great weekend. If you want to share out a story, you need someone to talk to, send me an email. I got plenty of time on my hand. I love to hear how you guys are doing. So with no further ado, I'm going to kind of get started with today's lesson. So you probably want to, if you're taking notes, I'm not doing any notebook checks or anything like that, but if you are kind of keeping up on yourself, then now's a good time to get your notebook ready. Let me switch this over. Make it look like this. So today we're going to talk about three forms of quadratic functions, and we've already talked in depth about two. All right. So right before this whole fiasco started, that Friday lesson was about substituting opposite of b over 2a in key features. Kind of rambling here again, but if you take the key features of quadratic functions, go back in your notes there, particularly in standard form, the opposite of b over 2a was how you found the the axis symmetry. And then you substitute that in to find the vertex. All right, fast forward 2 weeks. Then we looked at Desmos to see, hey, there's another way to find the vertex if it looks a certain way, called vertex form, right? But if it looks like you got a group squared and some shifting, if you got a group squared and some other parameters, then you know you can find the vertex another way. Basically thinking about offsprings or transformations of parent functions. So we've already kind of seen two of the methods, and today I'm going to outline the third one, or at least introduce it, and then we'll really look at it tomorrow. So again, we're looking at three forms of quadratic functions all this week in their applications, and hopefully put some closure to this by Friday. And next week, move into new ideas. All right. So my goal this week is to wrap this all up, one big package, and move forward. So the three forms are called standard form, vertex form. Those two you've seen in this course so far. And the last one's intercept factored form. You've seen it in this course, but not in the terms of graphing. All right. We factored earlier this semester. Splitting the middle is factoring. Okay. So guess what? It's coming back. Splitting the middle is what we consider factoring. Now you can actually graph after you have factored form, or maybe it's already given to you in factored form. You don't want to change it, right? The whole goal of this week is to say, identify which form you got and then work with that form. Don't do any algebra. Work with what's given to you to find the vertex, all right? So that's the goal of the week. And we have one final form, number 3 there, the intercept factored form. But I'm going to go through continually all week, if I start to get redundant and you're like, oh my God, I got it. Awesome. That means you learned it. All right. But bear with me. I want to get everyone here. So you're going to hear me say a lot of these things over and over and over again. Oh, we have standard form. Here's what we do. Oh, we have vertex form. Here's what we do. Oh, we have factored form. Here's what we do. But that's the goal. All right. Oops, there we go. So standard form. What is standard form? It's when you have, I want you to think like, it's expanded. It's already foiled. All right. There's nothing else to do. You cannot combine like terms. So for instance, right there, I'm jumping ahead, but I'll go back there. So here's an example of standard form. Negative 3x squared plus 6x minus 5. You can't combine x squared and negative 3x squared and the 6. You can't, and the 6x. You can't do anything with that expression in terms of combining like terms and foiling, nothing, right? That's your big clue that you have standard form. So the multiplier of x squared we call a, the multiplier of x is called b, and the number part that doesn't have any variable at all is called c. That's what standard form is. When you hear that, that's what you're thinking. Or that's what's being referred to. How do you find the vertex in standard form? To find the x coordinate, you take the opposite of b and divide it by 2a. Did this quite a bit. So looking back here, b is the number or the multiplier of x. You take its opposite value, and then you multiply 2 times a, and you do the division there. All right, and we're going to work out an example in about 20 seconds. How do you find the y coordinate? You substitute that number you just found into the expression, and that's your y. All right, so with no further ado, let's work one together. So you definitely want to copy this down. Y equals negative 3x squared plus 6x minus 5. To find the x coordinate, and sorry if there's a little noise here, I'm just switching to my tablet mode. Well, let's see. We have the following. A is negative 3 because it's the multiplier of x squared. B is 6 because it's the number that's multiplying the x. And C is negative 5. Not that it's going to be important here, right? So the formula for finding the x coordinate of the vertex when it's in standard form is negative b divided by 2a, or opposite of b. So we're going to have negative 6 divided by 2 times negative 3, which makes an ultimate value of 1. Great. So now we substitute 1 in negative 3. Let me just set this up. And I've mentioned a couple times now, if you've been keeping up in the classwork, that you don't have to do this by hand. You can just straight up type this into a calculator and you're good to go. I'm going to do this out by hand just because my calculator is in the other room and I'm not going to go get it. So bear with me for a moment. All of this makes negative 2. Right. So ultimately, I'm just going to write this over here. The vertex, the x coordinate is 1. The y coordinate is negative 2. Right. And that's how you find the vertex when given standard form. Okay. So we've practiced it, or hopefully you've practiced it plenty of times, even prior to this remote learning session. Right. So trying to give you an idea where to find this in your notes. And then even when we came back into this remote learning session, like Monday and Tuesday's lesson last week, kind of reviewed that. Right. So that's standard form, just reviewing it, kind of, again, trying to build a nice package here so we can ship this off and move into other things starting next week. The big goal last week was vertex form. We started looking at Desmos, and I've told a story about how you have a parent and then these are their children, their offspring, and they're basically just shifts. So how do you know you have this thing called vertex form versus standard form? Well, you're going to think in your mind, do I see a group, a set of parentheses being squared? If you have that, that's your clue that you have vertex form. And I said a few minutes ago that our whole goal is to be able to work with that. All right. Some teachers teach how to expand this and foil it all out. And listen, that's just a waste of time. I'm teaching you the shortcuts. I'm teaching you kind of some tricks here that whatever. I'm going to help you out. So when you see this, you say, oh, I have a different form, right? I have that group is the biggest clue. I have an offspring of the parent. And so you got to remember how to deal with that. To find the X coordinate, you're going to think inside opposite the group. That's my shift left or right, but you're going to go opposite your thinking, right? And the work that was submitted on Thursday and Friday last week, you guys did great. And today's warm-up is going to continually ask you to reinforce that, all right? So you should have done the warm-up already on Khan Academy where you're practicing finding the vertex and practicing identifying the shifts, all right? That's the most important part with that. But if you've got it, awesome. You should fly through it. If you're still getting there, awesome. You're getting there. And if you haven't got there yet, come on, join the rest of us. You're falling behind, but we want to get you up. All right. So anyhow, with no further ado, let's do an example of this. Again, this was kind of drilled last week. This was the main point of last week. So I want to make sure you got it. So suppose you're given 7 group x plus 3 squared minus 5. You should immediately say, I got a group squared. This is an offspring of the parent. So what we're going to do here is just to find the x coordinate of the vertex, you say this is inside the group, inside opposite, minus 3. That's it. Done. And the y coordinate of the vertex is your shift down, your outside effect, down 5, negative 5. Vertex ultimately is negative 3, negative 5, done. That's it. So this is why you don't want to do any algebra, right? It's simple enough. It just knowing your transformations and working with that. So moving forwards into the new topic or the new form of this week. Again, the goals this week is this, what you're seeing today and the big picture, all 3, right? So keep that in mind as we move forward all week. Called the intercept factor form. Said it before, probably twice, third time. We factored many times this year. Continually think, split the middle of greatest common factor. So you're gonna see that this week, right? But if you have that factored form, if it's already factored, do not FOIL, do not expand. We're going to say, how do I work with this? All right. Well, this is the last main point of today's lesson, and I would say the new part of today's lesson. You're going to average the numbers. Let me rephrase that. You're going to average the opposite of the numbers in the group. Ooh, that was a mouthful. So that's what this says. When you add 2 things and divide by 2, that's called an average. If you have a test score and another test score and you add them up and then divide by 2, that's called an average. So that's what that formula says. Take 2 things, add them, and then divide by 2. That's an average, ladies and gentlemen. So let's go back. What are P and Q? Well, P, let me get my little highlighter here. P is inside the group. Is it? Minus P is inside the group. Q's right here. Is it really? Well, minus Q's inside the group. So my friends, my students, what is P? It's the opposite of the number in the group, just like we've seen before. What is Q? It's the opposite of the number in the other group. So I'm going to be careful when I use the word group. In factor, let me go back. In vertex form, you have one group, one set of parentheses raised to the second power. In intercept form, you have 2 groups with different values. That's kind of fundamental to helping you understand the difference between the forms. So to find the x coordinate of the vertex in factored form, you take the opposite of the number in the first group, you take the opposite of the number in the second group, you add those values together and divide by 2. I try to think average. I find students find it better when they think average. To find the y coordinate, you substitute that average value back in and evaluate. That's very similar to standard form. So I'm going to end with this example. We're going to find the vertex for a quadratic function given in factored form. To reemphasize the point, how do I know it's factored form? I see 1, 2 groups not raised to the second power, and they have different values. Switch this to full screen for you. So I'm going to switch back to my marker, and I'm going to say P is the number opposite of that group, and Q is the number opposite in that group. So to find the x coordinate, we average P and Q. 3 plus -6 divided by 2. That's called an average. 3 plus -6 is -3 divided by 2 is -1.5 in my calculator, right? So if you get a fraction or a decimal, no stress. You can deal with it. Now we take that number and we substitute it in. We substitute that in to the original function. Right, -1.5, -1.5. Again, I don't have my calculator with me right now, so bear with me. I'm going to have to do some decimal work in my head. This is -4.5. This is positive 4.5, interestingly enough. This ultimately becomes 9 I got to do some fractions. Sorry. Definitely use a calculator. I'm going to do this to the side work here. Positive for sure. 18 over 2. Right. 81 over 2. Which is 40.5. I hope my work is right there. Probably should go back and check this on the calculator. I think I really should have checked this before. But so I'm going to put a little question mark there. It's Monday morning. I did have some coffee, but the main idea is definitely substituting the -1.5. That I'm positive that's what your x coordinate is. So apologize for being a little messy there, but that's how you would find your y coordinate. Okay, you're going to substitute the average value back in and then just let the calculator do the work. So I guess I should kind of wrap this up and say the vertex, I'm 90% sure, is -1.5, comma 40.5. A little bit messy because it's not in tablet mode, but all right, my friends, please check on Google Classroom for your assignment. All right, you have 2 warm-ups on Khan Academy, different Khan Academy this week. So warm up on there, re-emphasizing vertex form, the offsprings of the parent form. Okay, I really want to solidify that. And then you'll see an assignment that asks you to start to deal with the 3 forms of quadratics. There's no more to come, right? Again, last time kind of put our forms together in this nice little package, emphasize it this week, ship it off, and move into new territory next week, new content next week. But yeah, look at the Google Classroom for your assignment. You're going to submit it, either taking a picture with your phone and uploading it onto Google Classroom, or scanning it and also putting it in Google Classroom. So happy Monday to you. Good luck with the rest of your coursework. Please feel free to email me with any questions, and I'll see you tomorrow.